Let's take a look at this example. We're supposed to design a half adder. Half adder has two inputs and two outputs, okay? And basically what we're supposed to do, we're supposed to add these two bits together, okay? So I have 0 plus 0, okay? I'm going to write over here. 0 plus 0 is equal 0. But because we are going to have two outputs, I'm going to write 2 bits. So this is my binary 0, 0, 0, where the least significant bit represents the sum. So I'm going to have over here 0, and the most significant bit of my result is represent carry out. Okay, so this is also 0. We have another combination, 0 plus 1. So I have 0 plus 1 is equal binary 1. So I have 0, 1. So I have 0, 1 because the least significant bit is my sum and the most significant bit of my result is carry out. 1 plus 0. So I have 1 plus 0 is equal again 1. Okay, so I'm going to write over here 0, 1. 1 plus 1, 1 plus 1 is equal 2. So binary 2, 1, 0, where 0 is going to go over here and 1 will go over here. Okay, so other words, 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 0 is 1, and 1 plus 1 is 2. Now we're supposed to draw the diagram. Please notice that we have two inputs and we are going to have two outputs. Okay, if you are going to look at this column called carry out, this figure is supposed to remind you something. This is nothing else, just the AND gate truth table. Okay, so this is AND gate. If you are going to look at this column, this figure is supposed to remind you that this is nothing else, just the truth table of the exclusive OR gate. Okay, so now we can draw the circuit. Okay, so as we said earlier, we have two inputs. We have input A and we have input B. Okay, we have two inputs. Now we have these two inputs connected to the exclusive OR gate. Okay, so I have my exclusive OR gate, and the output of exclusive OR gate is going to be my terminal called the sum. Okay, and now we're supposed to look at the column carry out. Carry out, we said this is AND gate. Okay, so we have the AND gate connect to terminals A and B. So I have AND gate, and this is my second input. Okay, and the output of my AND gate is called carry out. Okay, so we can say that we design the half adder.